Hey everyone, it's your cranky classmate here. We're going to knock out an AP Calc Unit 3 FRQ. So everything to do with chain rule, implicit differentiation, and this unit has to do with inverse. I don't think there's an inverse question on this FRQ, but let's get it. So we're given this curve in terms of x and y, and we're asked to show that dy dx equals all that. So the first thing that you need to think of whenever you just see any implicit differentiation questions are your differentiation rules, like power rule, chain rule, quotient rule, and product rule. So, we're gonna get good practice with all of them today. The first thing, start out with each term individually, right? That x cubed, that's just power rule. Bring the 3 down, x, and then 3 minus 1 equals square, so 3x squared. Plus, remember, just adding terms there's no rule for that with finding the derivative. Just add the derivatives times. Now, you're trying to find the derivative of y with respect to x. But remember chain rule, right? If I have something like 2x minus 2 squared, find the derivative, I just treat the 2x minus 2 as its own term, so I use power rule. And then I find the derivative of the individual part, the inside part. And that's the derivative of 2x minus 2 whole squared. So, similarly, you can just think of y as a function of x, right? It's not just a variable itself. It can also be written in terms of x. So what does that mean? So that means to just do power rule on the outside. The outside, in this case, being being the y. So 2y times dy minus dx. That's the inner part of y as a function of x. So that all equals, and now I see terms being multiplied, so product rule. My first term would be the 2x. You could take the 2 out too, and just multiply that at the end, and I see the second term as the y. So, just find the derivative of 2x, 2, multiply that by the y, plus, find the derivative of the y, which is dy dx, times the 2x. Now we need to bring the dy dx's the same side. This is just a little algebraic manipulation. I see here the answer that they already have it as 2y minus 2x. So just to save myself an extra step, I'm going to subtract this over. I'm going to bring that over to this side. So what I get 2y dy times 2y times dy over dx minus 2x times dy over dx, which equals to 2y minus 3x squared. Okay. Now what you do, just factor out the dy minus dx's. So take that out, and inside you'll be left with 2y minus 2x equals 2y minus 3x squared. And I think you can see where we're going from here. Divide by this, and you'll get dy over dx equals 2y minus 3 squared over 2y minus 2x. And they literally give you the answer, so just double check, and looks good. All right, next question. Find the equation of the line tangent to the equation above at the point -3, 3. So immediately when you see a tangent line, or even when it comes to linear approximation, just think of point-slope form. And what that is you can write a line as, you're familiar with y equals mx plus b, but it's also simpler most of the time to just do y minus y1 equals to m times m being your slope, x minus x1. And this is used given a point x1 comma y1. And you see here, we're literally given a point x1 comma y1 in a sense. So we have our we have our x1, we have our y1. All we need is our slope. And what do we know slope is? It's just the derivative at a point. The derivative of a function at a point. So we have dy dx, which is just in terms of y and x, and we have x and y at those points. So just plug in these points into dy dx up here. So you'll get 2 times 3 minus 3 negative 3 whole square. And just for our AP grader, we're going to label the fact that we're evaluating dy dx at 3 comma negative, sorry, negative 3 comma 3. So you get that as the numerator, and then the denominator you get 2 by 3 minus 2 times negative 3. Let's evaluate this. 6 minus 27 over 6 plus 6, get negative 21 over 12. Divide the numerator and denominator by 3, and you'll get negative 7 over 4. You don't need to simplify it either, but yeah. Now this is just your m value. So all you need to do, bring this down, and let's just plug in. Y minus, what is our y1? 3 equals our m, negative 7 over 4, times x, and our x1, minus negative 3, so just plus 3. And that's your answer. Really simple. You don't need to simplify it into y equals mx plus b or anything. Part C. Find all x values on the graph where the tangent line is vertical. So this is a concept that you need to know with implicit differentiation, where you may think, and yeah, that's right. A tangent line is basically when the graph has an infinite slope at a point, right? And think about the ways you can get to infinity. You can do that when you just are essentially dividing by 0. So what you want is your numerator here to equal 0. But you know what you can't tell if this is vertical? If your numerator also equals 0. Because then what? You get 0 over 0. So, and that's, we just can't really mathematically tell what's going on. So, to tell if you're vertically tangent, you want to make sure your denominator equals 0, but your numerator does not equal 0. So what do? Just set your denominator equal to 0. You'll get what? 2y minus 2x equals 0. 0. 2y equals 2x. Y equals to x. Okay, so then what you want to do, you already have this original equation up here. Just plug back into that. And since we're solving for x, I'm going to substitute all the y's with an x. So what that's going to get me is x cubed plus x squared equals 2x times x, so just 2x squared, right? And I'm going to subtract by 2x squared on both sides, so I get x cubed minus x squared equals 0. Now this is a big step here. You want to make sure that you do not bring over the x squared to the other side, divide by x squared, and just get x equals 1. This is incorrect. Remember that you just can't divide by 0. So what you're essentially missing out on is external solutions. In this case, you would be missing out on the solution of x equals 0. Right? So you don't want to do that. You don't want to do this. What you want to do instead is just solve it like factoring a polynomial. So just factor out the x squared, x minus 1 equals 0. And now what we can tell from that is that this equals 0 at, so not sign. Okay, at x equals 0 and x equals 1. So now what do I want to do here? At the end of the day, I just need to check that the numerator does not equal 0 at these points. How do I do that? First, I can tell that the numerator has a y in it. So let's just solve for y at these points. So when x equals 0, you get 0 plus y squared equals to 2 times 0, 0, y equals 0. So now at y equals 0 and x equals 0, the numerator of your derivative is 2 times 0, so 0, minus 2 times 0 times 3 times 0 square equals 0. But that's a big, we can't have that. So therefore, we can reject this x equals 0 as a solution. Let's check x equals 1. It's the same thing. Plug back in. You get 1 cubed, so 1 plus y squared equals to 2 times 1y, so 2y. And then you'll get y squared minus 2y plus 1 equals 0, which should just be y minus 1 whole square equals 0. So y equals to 1. So now at x equals 1, y equals 1. What does dy dx equal? Well, 2 times 1 minus 3 times 1 squared, which equals to 2 minus 3, equal to negative 1, which is not equal to 0. So this passes the test. This is fine. And therefore, x equals 1 is our solution. X equals 1 is the only x value where the tangent line is vertical. Finally, find the second derivative, d squared y over dx squared. That's what that means in terms of x and y. So the way you always want to approach this, don't get really startled. Just consider that find the second derivative, you just take the derivative of the first derivative. And you already have it right here. So, and it looks like we're going to use a quotient rule on that. So let's do that. So d over dx, the derivative with respect to x of 2y minus 3x squared over 2y minus 2x is equal to, so for quotient rule, remember, if I split this up into green and blue, you're going to want to do green prime times blue minus f prime green all over f square. So in this question, that would just be, so there's implicit differentiation going on within multiple parts of this. So g prime is just what, 2 dy dx minus 6x minus f prime is 2 dy dx minus 2, that all times the numerator, all over 2y minus 2x whole square. Now you see we have the dy dx's left, but don't worry, we have dy dx given to us in terms of x and y right here. So all we need to do, it is going to look a little messy, but all we're going to need to do is just plug in that 2y minus 3x squared over 2y minus 2x into where we have 2 dy. So I'm going to quickly write this out. And yeah, that should be your final answer here in the green. So yeah, it's pretty long, it's pretty messy, but you don't need to simplify this at all. All you need to know is just plug in that dy dx back in, and you can get your second derivative. So yeah, that is how you go about these FRQs. Just one note on part C here. Here we're doing it vertical, right? But if we were doing it to be horizontal, just do it the other way around, where you're looking for your numerator to equal 0, while your denominator cannot equal 0. But otherwise, yeah.
Hey there, it's your cranky classmate here, and I will be going over this Unit 3 chain rule, implicit, and inverse MCQ here. So we got question 2 here. We have if y equals arc sine of x squared minus 1, then dy dx equals what? So dy dx equals, so first we need to do chain rule. We have to take the derivative of this outer function, arc sine. Derivative of arc sine is 1 minus square root 1 minus, and then x squared minus 1 squared. But then we also have to multiply by the derivative of this inner function here. The derivative of x squared minus 1 is just 2x. So this becomes 2x divided by square root 1 minus x squared minus 1 whole squared. Now this doesn't really look like any of our answer choices here, and that's because we need to expand this x squared minus 1 whole squared. So 2x divided by square root 1 minus x to the 4 minus 2x squared plus 1. And now we just need to distribute this negative to the x to the 4 minus 2x squared plus 1. 2x over square root 1 minus x to the 4 minus 2x squared, plus 2x squared minus 1. Cool. This 1 and this negative 1 here will cancel out, leaving us with just 2x divided by square root negative x to the 4 plus 2x squared. And that looks like that's answer choice A here. Great. Now let's move on to question number 2. Question number 3. If y equals sine 2x, then the third derivative of y is equal to what? So let's take dy dx. Dy dx equals, again, this is another chain rule question. We have to take the derivative of this outer function, which is cosine 2x, and then multiply that by the derivative of this inner function. The derivative of 2x is just 2. So this becomes 2 cosine 2x. Now we do this again. D squared y dx squared equals the derivative of 2 cosine of this outer function is negative 2 sine 2x, and then again multiply that by the derivative of the inside is just 2, so that becomes negative 4 sine 2x, and then we do that one last time. Dx cubed equals, again, the derivative of the outside, negative 4 cosine 2x, and then multiply that by the derivative of 2x, which is just 2. This becomes negative 8 cosine 2x, which is answer choice A. So moving on here, we have number 4. If f of x equals 5 over x plus 2, and g is the inverse of f, then g prime of 3 equals what? So to solve this, we have to use this formula that says g prime of x equals 1 divided by f prime of g of x. We have to use this formula. And to use this formula, we need to find out what f prime of x is and what g of x is. We need to find the equations for those. So let's find f prime of x first. F prime of x equals, the derivative of this is negative 5 over x squared. That's just some power rule there. And the derivative of plus 2 is just 0. And now to find the function for g, well, we know that g is the inverse of f, right? So if we say y equals, I'm just writing out the function for f here. If we know that g is the inverse of this, we can just switch x and y. So we can say x equals 5 over 5. X equals 5 over y plus 2. So x minus 2 equals 5 over y. So then y equals 5 over x minus 2. So this is the function for g of x. Now we can plug into this formula. G prime of 3 equals 1 divided by f prime of, now if we plug in a 3 to this function right here, we get 5 divided by 3 minus 2, which is just 1. Now 1 divided by f prime of 5 is equal to negative 5 over 5 squared. Now this, when you evaluate it, comes out to negative 5, which leaves us with answer choice B. So number 5 here, we have if the function f is given by f of x equals natural log of cosine pi over x, what is the instantaneous rate of change of f at x equals 1 over 4? So again, we can say dy dx equals, we do chain rule again here. The derivative of this outside function is 1 over, and then cosine pi over x here. And then we multiply by the derivative of this inner function, which is negative sine pi over x. And then again, we have to use chain rule here because we have this inside cosine pi over x, we have that function there. So the derivative of pi over x is negative pi over x squared. So I'll just rewrite this. This becomes pi over x squared, because those negatives cancel out, times sine pi over x over cosine pi over x. Now if we plug in a 1/4 here, sorry, that should not be an equal sign, we get pi over 1/4 squared times sine of, pi over 1/4 is just 4 pi. 4 pi over cosine of 4 pi. But here's the thing, sine of 4 pi is equal to 0. So this entire thing is multiplied by 0, and we're just left with 0. So the answer is B. Moving on, we have number 6 here. If x plus y to the 1/4 equals y, then what is dy dx when y equals 16? So the derivative of x is just 1. The derivative of x is just 1 plus 4 times, now we use power rule here, we bring this 1/4 down, multiply by y, so the negative 1/4 minus 1 is just negative 3/4. And then since we just we took the derivative of y, we have to tag it with a dy dx here. And then this is equal to the derivative of y on this side, that's equal to 1, again, dy dx. So now we solve for dy dx. That 4 and that 1/4 cancels out. So y to the negative 3 over 4 times dy dx, minus dy dx here equals negative 1. If we factor out a dy dx, we get y to the negative 3/4 minus 1 equals negative 1. So we get that dy dx equals dy dx equals negative 1 over y to the negative 3/4 minus 1. And if we evaluate this at y equals 16, we get negative 1 over 16 to the power of negative 3/4 minus 1. Now this is equal to, 16 to the negative 3/4 is equal to 1 over 8. And then minus 1 here, this is equal to negative 1 over negative 7 over 8. This negative cancels out. This is equal to 8/7, which gives us D. And finally here we have number 7. If dy dx equals square root 1 minus y, what is the second derivative of y? So we have d squared y by dx squared equals, again, this is another chain rule, because we have this square root 1 minus y here, so we take the derivative of the outer function, 1 divided by 2 root 1 minus y, And then we multiply by the derivative of this inner function, 1 minus y here. That's equal to negative 1. Again, you have to tag it with the dy dx since we're differentiating y. And we know we were given what dy dx equals in the problem. So we can plug that in, plug this square root 1 minus y in for dy dx. This gives us negative 1 times square root 1 minus y divided by 2 root 1 minus y. This root 1 minus y on the top and bottom cancels out, which leaves us with just a negative 1/2, which gives us answer choice B here. So I hope you're feeling more confident on Unit 3, implicit differentiation and chain rule. I hope you ace your next exam, and please, if you found this video helpful, please like, comment, subscribe. And if we get 500 likes, I'll convince my teacher to dye his hair blonde. So, thanks for watching, and I'll see you later.